All right, class, next section, 6.6, Use Proportionality Theorems. So the first theorem is 6.4, Triangle Proportionality Theorem. And it states, if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. Proportionally. So what this is talking about is if TU is parallel to QS, and that's marked for us, we can see that TU intersects the other two sides. And it's what it means to divide those sides proportionally. We're going to say that RT is going to kind of match up with RU and TQ with US, and we'll have we can make a proportion with QT and RT and SU and UR or RU. So if I say RT over TQ will be equal to RU over US. I would be dividing those sides and proportionally. Those sides are now proportion. So we've got our long sides in red on top and the shorter sides in green on bottom. Our second theorem is 6.5, which is converse of the triangle proportionality theorem. It states, if a line divides two sides of a triangle proportionally, then it is parallel to the third side. And notice this is a converse. Remember, converse is switching the hypothesis and conclusion. If our previous one, the triangle proportionality theorem, is stating if a line is parallel to this other line and intersects the two other sides, then it divides the two sides proportionally. So this is the converse of that, switching it. If it divides the two sides proportionally, then we know it's parallel to that third side. So looking at this, if we know RT over TQ is proportional to RU over US, meaning they're the equal proportions, then we know that TU is parallel to QS. So that's the converse of triangle proportionality theorem. So proportionality theorem is if you know the lines are parallel, then you know the divided up sides are proportional. And the other is if you know the two sides of a triangle or have that triangle proportionality, then the third side is parallel. So let's put this into practice. Find the length of a segment. In the diagram, BE is parallel to CD. All right, we see that those are parallel. And we know AB equals 8, and BC equals 12, and ED equals 9. We need to find the length of AE. Well, because we know BE is parallel to CD, I know that our sides are divided up proportionally. So AE here I'll call X. When I set up my proportions, I would say everything along this line is set up together. So if I would say 8 over 12. And then everything along this side would be together. And so it would be equal to X over 9. And then I just need to cross multiply, solve for x, and then I know the side of AE. So 12 times x gives me 12x. 8 times 9 gives me 72. Divide that by 12. And x equals 6. So side AE, which we're trying to find, equals 6. In our next example, we're determining whether the line segments are parallel. So in this diagram, we see that side PQ divides LN. So here's PQ. It says that it divides LN and MN into the lengths shown. Determine whether PQ is parallel to LN. So we want to set up proportions here and then find out if they are parallel. So our proportions are, we have 16 over 18. That would need to equal 24 over 27. If these simplify down to the same fraction, same simplified fraction, and they're actually equal, then we know the lines are parallel. So what is the greatest common factor of 16 and 18? It would just be just be 2. So we divide 16 by 2 and get 8. Divide 18 by 2 and get 9. So now we need to see, does 24 over 27 simplify down to 8 over 9? Greatest common factor of 24 and 27 is 3. So 24 divided by 3 is 8. 27 divided by 3 is 9. So yes, because they're parallel, or yes, because they're equal, the proportion is equal, they are parallel. Yes, they are parallel. Example 3. Here we have a spoiler. I know it looks like a great picture of a spoiler that you might see on a car, but this is for like on a remote controlled car, so it doesn't have to look too awesome. But we have a spoiler for a remote controlled car. We're told that AB equals 31 millimeters, BC equals 19 millimeters, CD 27, DE 23, and we want to explain why BD is not parallel to AE. Sorry. So I'm actually going to redraw my triangle a little bit bigger so we can see our proportions better. All right, so we were told AB equals 31, BC equals 19, CD equals 27, and DE equals 23. So we want to set up our statement, set up our proportions. So we have 19 over 31 equals 27 over 23. We can cross multiply here. So we could simplify, see if we come out to the same numbers. We can also cross multiply and see if we come out with the same numbers. So 19 times 23 gives us 437. And 31 times 27 gives us 837. So those do not equal each other. So they are not parallel because the sides are not proportional. If we tried simplifying 19 and 31, they don't even simplify. That's as simplified as that fraction gets. 27 over 23 can't simplify either. So really, they're already simplified as they are, and if they're not the same, and they're in their simplified form, they can't be equal. But this cross-multiplying is another way we can determine that also. So instead of, if you're not good at simplifying, cross-multiply using your calculator, write down what you have. If they don't come out as equal, they're not, it's not going to work out, and they're not proportional, and they're not going to be parallel. So not parallel. Because sides are not proportional. Next example, we want to find the length of KL. So I'll call KL X. We see that my lines are parallel. JN is parallel to KM. So I know that these divided up sides are going to be proportional. So if I have X over 18, I know that is equal to 44 over 24. Then I can cross multiply. X times 24 gives me 24x. That's going to be equal to 18 times 44, which is 792. I divide by 24 to get x by itself. Find x equals 33. So side KL equals 33. Next, determine whether QT is parallel to RS. So we have all of our line segments up there. We need to set up a proportion and find out if they're equal. So if I have 18 over 38, it needs to be equal to 36 over 80 for those to be parallel. So we can cross multiply or simplify, either way. Either try and simplify them or cross multiply. 36 and 80 kind of big numbers. Maybe we don't want to simplify, but we can punch them into a calculator easily enough. 18 times 80 is 1,440. And then 38 times 36 is 1,368. So they are not equal. So no, they are not parallel. So using the triangle proportionality theorem will show us that our side segments are proportional. And then the converse of that is using those proportion sides to show that lines are parallel. So that's it on the notes. Make sure you do our 6.6 homework.